we go. System.
Joshua. Do an Apple charger, bro.
Okay. Collection. Okay, a system is a collection of two or more equations, a solution to a system, okay, is where the graphs intersect. Okay, so the key word here is the solution is the intersection. Because we're going to solve graphically today, so we want to know where the graphs intersect. When are they in the same place? Okay, so we have one more word, solution point. Okay, so a solution point is when an actual point, x comma y, is two or more equations. Yeah. Substituted the result is a, okay, solution means true statement. When you were in Algebra 1, you graphed linear systems, and you had one solution when the two lines crossed once. You had no solutions if the lines didn't cross at all. And you had infinite solutions if you had the same line. That's the review. Okay? Linear systems, you could have two lines that crossed once. You could have two lines that crossed not at all because they were parallel with different y-intercepts. Okay? Or you can have a system that ended up with the same line. Well, this is now quadratic. This is not linear systems. We're going to have quadratic. Okay? So the first set of examples we're going to look at are linear, quadratic systems, which means we're going to have a parabola and a line. Same idea, how many solutions, but now we have different types of graphs to look at. So the first thing we're going to do is try to draw a picture. So we have three sets of pictures to draw. The middle section is bigger on purpose. I'm just going to start with a parabola, right? Linear, one line, one parabola. Draw a line that crosses twice. Okay. Draw a line that crosses that parabola twice. Okay, this is two real solutions. Because there are 2 points on the graph where they intersect. These are the solution points, right? Those points. The solution is where they intersect. That's actually a solution point. If I were to plug it in, it would result in a true statement. Okay? We're going to draw 3 little pictures here. 3 little ones. That's why the section's a little bit bigger. Okay, I need you to draw a line that only touches that parabola once. Yeah, we're going to draw a line 3 times that looks different but only touches once. Right? I want to know how many solutions I'm going to get. So I could get 2. I could get 1. 1 real solution. Anyone have a suggestion on what kind of line will only touch the graph once? Straight down the middle. Actually, any vertical line will do it, but the axis of symmetry is a pretty easy one to pick out. Yeah. Some vertical line. Okay, I need another line. Only touches once. Yes? Yes, it could go diagonal. It's a little tricky to draw that one, but yes, it could go diagonal. Okay, one more type of line that only touches once. Maybe put your pencil there, right? Move your, which line only touches once? Yeah. Yes, very nice. Okay. All right. We're going to add a vocab word here. These two have a special word that goes with it. We call it tangent. Oh gosh, geometry. Okay, do you remember your circles? Do you remember your circle from geometry?
No, stop.
Yes,
please.
you do.
No circles. No circles.
Okay, circle. A tangent line was the line that went like this. Look at my picture. Tangent line touches my circle once. Like that. The line is on the outside of the curve here. Okay, look at this. Sort of like the bottom half of the parabola. Looks like that circle right there. It's called tangent because it touches the curve once and kind of bounces right off. This is not tangent, guys. That's like almost perpendicular. That is not tangent. This is tangent. Think of that circle diagram that you're used to. This is tangent, where it touches the curve, kind of bounces off. It stays on the outside of the curve. That is a tangent line. There's actually another word that goes with this. It's called a double solution. All right, we've talked about double. This tangent point is a double solution. One real solution. Those two pictures happen to be doubles. All right, our last one is 0 real solutions. Draw a picture where the parabola and line don't touch. There's, I suppose, 3 particular lines that you could draw. Any suggestions on how to draw a line that's not going to touch this? Yeah. Yep. Okay, so I'm going to draw my line too low, right? Below the vertex. Yep, that doesn't touch. How about another? On the side. Slanted or not slanted? Yeah, it's got to be slanted. It's got to be getting, notice here the edges are getting further apart. I want to make sure they're not going to touch. Yes. I suppose I could draw a negative sloped one, but that's really the same as this positive sloped idea. Okay, 0 real solutions. Typically, you don't solve systems graphically by hand because your graphs have to be too accurate. We only plot 3 points on a parabola. How is that supposed to be able to find these points exactly? It doesn't. Okay? Which is why we're going to do our graphing in the computer today. We're going to sketch and check with our computers. So let's actually solve a system. Okay? We're going to solve graphically. And then we're going to, right next to it, do the algebra that matches. Solve with Substitution. Okay, here is your system, which is going to be a collection of two equations. Y equals okay, so what I want you to do is try to sketch the picture yourself to see if you can figure out which category we're in, 2, 1, or none. And then we'll actually look at it. Mm-hmm. 1, 2, 3, 1, 2, 3, 4.
Doesn't need to be accurate, or can we just sketch?
Sketch is fine. Okay. So there's my picture. It looks like one solution. Now it is sometimes too hard to tell with a sketch. So what we're going to do is you're going to go to your Desmos. Okay? And we're going to try it. Oh. Okay, so you're in your Desmos. You're just going to type the two equations here. Now down here in this bottom left corner, you should see a keyboard button. If you click on the keyboard button, it gives you things like x's, y's, parentheses, squares, square roots, absolute value, numbers. You can also just type y equals parentheses x minus 3 parentheses. Now I need an exponent. If you press the shift 6, it's the caret key, it's the up arrow, it moves your cursor to the exponent slot. And you can see the graph, it starts popping up once you get something there. And then I'm moving my cursor over, plus 4. Oh, plus 4. And then you can just click on the second line and type in the next one, y equals 2x minus 3. And then I'm going to move this down so I can see it. There's my picture. Looks pretty reasonable. Looks like what I sketched. Now the reason that we do this here, Desmos is really nice because if you click on that red graph, look at the gray points that it highlighted. As Desmos will automatically highlight the key features. The vertex, automatically, the point pops up. The vertex. So now I'm going to try clicking on the blue graph. The intercept pops up. All the key points pop up automatically in Desmos. See this gray point right here? The intersection automatically highlights in Desmos. It does not do that in your calculator. Okay? Now you do have access to Desmos on the SOL and some other standardized tests, which is why we're going to look at it. We will continue to look at our calculator as we have more opportunities, but I want you to be able to use this. Okay? So right there, the intersection is 4, 5. Okay? Let's go back and label our point. Solve the system graphically. So I sketched my picture. I used my computer to check it, and I'm going to write 4, 5. And I'm going to add the vocab words with it. It's a tangent or it's a double solution. Tangent, solution, because it touched in just one place on the graph. It kind of right along the outside of the graph. Tangent, solution. In your homework, I expect you to graph them in the computer and then just transfer the graph to your paper and label the points. A solution is where the two graphs intersect. You need to label the intersection. That is the answer. Okay? Solve with substitution. We're going to do it both ways so we can see how the algebra works. See this? Y equals? Let's substitute. Set them equal. It's called substitution because we're replacing the y values. I'm graphing, it's in y equals, so let's substitute and start expanding and combining our like terms to see what the algebra says about this picture. Okay. And 9 and 4 and 3 is 16. And 0. Okay, it was quadratic, and so I'm trying to solve the quadratic by setting it equal to 0. And then I have to be like, okay, how do I solve a quadratic? Isolate, factor, complete the square. Pick one of them. I know we did a lot of complete the square. Don't forget about factoring. Pretty sure I can multiply to 16 and add to negative 8. Uh-huh. You mean a double solution? Because algebraically, I got the same number twice. This is what it looks like algebraically to get a tangent solution. The same number twice. Okay, but I need a solution. My vocab said it's where the two graphs intersect. X equals 4 is not actually a point on the graph. It's just an x coordinate. You need to make sure to go back and also find the corresponding y. So I have the x coordinate. I'm going to go back and find y. So my answer, algebraically, is 4, 5. I did it graphically. I'm doing it algebraically. Yes.
This is 4, 6, right?
4, 6 with a little bit of 4, 7, but
So this is not being placed on Tuesday?
correct. No, we won't do this until after. Yeah.
Will you tell us which one you want to do?
Yeah, I will tell you. And graphically, there is no reason to actually solve a system graphically by hand.
Oh.
You can't, your graphs aren't going to be accurate enough.
So can we use Detros on the quiz?
If that is what I'm going to ask you to do, yes. Before we're done, we'll look at what I could ask you without the computer. Okay? And it'll be more or less what transformation would result in no solution, where you pick me two parabolas that don't touch, or a parabola and a line that don't touch. Like, obviously don't touch. I'd probably go for comparing to that vertex. Okay? That's what I would ask you, is like, how many do you think this would have and why? All right. On your whiteboards, we're going to try a substitution, and then you can check it in your computer. All right? Try it. Anything off the ledge is fine. Okay. Go ahead and try y equals okay. Y equals negative . I'm going. Yeah. I have to, there's one more number here. Hold on, it's coming. Okay. Okay, try substitution and then type it in and check it. Yeah, graphing is more of a checking, right? Do the substitution, maybe sketch your picture, and see if it all corresponds.
You make it equal to 0. I'm sorry, you move the variables over to one side.
If you do 15,
Yeah, you have to make.
because this is y and this is y, so this is equal to
X is negative 3. Careful. X is negative 3.
Why'd you fix this one?
Right, do that substitution. See what you end up with.
Y
Right? Yeah.
into.
Yes, and now you expand and combine.
Oh, it's opposite, right?
Expand and combine. Yes. Mhm. So if I were to sketch the graph, I know it's tangent, I would just make it look that way in about the right place. Check your y coordinates. I agree. Okay, you forgot your. Yes.
Do I have to factor it?
Yes. Except that this is plus 2x. This is x squared plus 4x plus 4. Yes, there you go. And then when you sketch it, you would see that. Okay, hold on. This is a negative 2. There you go. That'll. Yes. Yes, good. Keep going. You're going to find your 1x coordinate. You end up with a perfect square trinomial, which is what gives you a double solution of x equals negative 3. And then I go back to my line. 6 minus 4, 2. So the coordinate is, all right, left 2, up 1. Graph looks like this. 1, 2, 3, 4. Looks like that. There's my picture. I know it's supposed to be tangent because of the double solution. Okay. Here we go. Y equals x squared plus 3. Y equals 2x minus 3. Yep, substitution. Okay, try it. Just try solving it. And then we're going to come back and say something about this one in our notes. Do it on your whiteboard, and then we'll see where we get stuck, and then we're going to come back and write a sentence or two about it. It's equal to 0 actually. Okay, equal to 0. Solve for x.
But you can't factor,
Isolate.
which means it's a perfect square or a complete square.
Isolate. You only have one x. You are solving. Keep going. Good. Okay. Uh-huh.
One negative.
Okay, if you get stuck algebraically, maybe go back and try to sketch that system. Okay, agreed. You lost your equals. That's fine. That should be a plus sign. Okay. If you get stuck algebraically, go back and graph the system. Graph it in your computer, that's fine. There's a Desmos app too that graphs.
Wait, so now
If you
you
wanna try.
solve it,
So it'd be
right?
Yeah, so then there's no solution. Which means no features.
plus or
This
minus.
is just a real solution.
Because you can't square root a negative and get a real number. Aha. How many x's do you see?
No, that
One.
makes sense, because if you think about
One.
it, the only reason we're
Isolate it.
solving is to see how many solutions we
Okay,
have.
so if you get stuck here, go
But
back and try to
since we know
sketch
how
the
many numbers
picture.
that it is not gonna
Okay.
be, it can't be real. Easy.
Should not cross. Okay, so I see that we are a little bit confused. You're like, how do I solve it? You're getting stuck at the equation where you're like, okay, 0 equals. And you're like, I don't know what to do next.
Complete square.
You could complete the square. You could not, complete the square. It doesn't isolate and it doesn't factor. Okay, so let's set up for completing the square in order to solve it. So plus 1, plus 1. And then I keep trying to solve it by isolating x because there's only one of them. X equals 1 plus or minus no real solution. I don't get a real number. Go back and graph the system. Okay? I do want you to put a note about this system in your notes so you have an example of no solution. Okay? So let's go back and let's sketch. 1, 2, 3, opening up. 1, 2, 3 with a positive 2 slope. I think it seems reasonable to say these graphs do not intersect. Okay, so we say no intersection, which means no real solution. That is your answer. So now you can see it graphically and you can see what happens algebraically. That is the connection between the two. Your answer is no real is because you got an I. No points on the graph where these things touch each other. Make sure that you know how to interpret the graph. I would, if I get stuck algebraically, I would go and check the graph. Oh, they don't cross. You can zoom in or out, click and drag. How do you know that you get no real solutions? Well, algebraically, you get an I. Graphically, you get no intersections. Okay, put a note about this in your notebook. I'll leave it up here. Put a note about it. How do you get imaginary or no real solutions? Graphically, algebraically. You can just write down part of it so that you know what this means. Okay. What do you need to be able to do? Type the graph in Desmos and check it. Second, you need to be able to do the substitution and solve your equations. Make sure that you can get all the way back to x and y coordinates. Okay? Keep your notes for reference. We're just going to try a couple. I'll put up a few systems. Try them on your whiteboards. We will do this for about 10 minutes, and then we'll stop. We'll start going over any homework questions if you have them, and then your quizzes will be the last 15 to 20 minutes of class today. All right. Solve your systems. Type them in the computer to check. I want you to practice typing. Here we go. You're just going to practice your substitution right now. Okay.
Can I get a drink of water?
Yeah, sure. I'm just going to put up a couple systems. You solve them as quickly as you can get to them. Yeah. You might be able to open the website also. Yeah, I'm not sure, but yeah, it should open pretty easily. It's meant for the phone and the computer. It's not like gonna stop working. Should be fine. Cool. It doesn't actually matter which one is on the left or the right. You're just replace. They're all in y equals because you're supposed to graph them. Means you're just setting the y's equal to each other. Okay. Okay, you're working on your substitution and your solving. Okay, so if those are the x's, what are the y's?
Wait, so if this one y, x equals 5, x equals 9.
So I get 2 x's. That means it's going to have 2 real solutions. Keep going. Make sure you find the corresponding y coordinates. That's where they should cross on the graph. When you type it in to check it, you should see 2 real answers.
What?
Okay, there's my graph. That's what you should see in your computer or your Desmos app. Make sure you can get all the way to the x's.
Oh, shoot.
Okay,
When I completed the square, I
this is your system. This is just the
Where's the high school
final
factor?
answer. Basically, it's like
Because if you get factor,
you can use it to help interpret how many answers.
if isolate factors, then we'll get this one.
Which really just means that my system has 2 solutions.
You literally had an entire packet on it.
Oh, so it's like this x minus
Yes.
1 x minus
Yes.
or 1. It might be plus 1.
5.
Okay, good.
Minus 5 plus
Which one
minus 5.
Second one, okay. I'll start writing up the answers.
X's,
See if you
5.
can find those solutions.
And then we plug them back in.
And then y.
It's just a lot of substituting. We did an entire packet on factor.
I know, but it's been a while, hasn't it?
So find the multiples of this. Find multiples of C.
How'd you staple that big
Please.
Oh yeah, you had multiple staples.
No, the copier doesn't.
Yeah, the copy is.
Okay, so you have your x's. Go back to the beginning and find the y. So 5 plus 1 is 6. You actually have 2 solution points. These are the coordinates. And so your final answer would be -1, 0, 5, 6. The actual points on the graph are your solutions. Okay, so there's 2 more. See if you can do the solving. Yeah, anyway.
I mean, at least it's not open, right?
They all solved in slightly different ways. Okay, don't forget when you do isolate the factor or complete the square. I would think we'll learn factor before you.
-5 is what?
Only because think of how much setup there is. There's a lot of stuff. Complete the square just
How is
another set of tasks.
That's really interesting.
Oh, you guys have the easy fashion secret.
Yes.
Coach Hutch is scary. Every time he's like yelling at us. He's like,
So it's either like 1
Oh,
and
dude,
5,
good
like
question.
yeah, well, he
Right,
has
vocab
freshmen.
plus application. Right? Can you just describe it? Can you actually use it?
What?
I was trying to. So like,
I mean, it's not directed at you guys. It's just some of the kids in the freshman class absolutely.
so now,
Yeah.
So like if he like super really
Today, he was scary.
She
He
was
literally
so
knocked
scared.
like 4 people off.
He's so
Yeah, he is.
like he famous for so much. Like my senior friend, he's like, oh yeah, I barely passed that class. We don't do anything. Oh, we got on board.
just trying to show you where it's not the messy. Try to show the setup. And if you want to write this, and circle the information that you're actually trying to use.
Yeah,
So that I can, you get a better score if I can tell what your reasoning is behind why you're solving the problem the way you are.
No, chill. Oh my god.
But if I can't see completely understand it.
Why is your whiteboard so gross?
Otherwise,
I know, right?
now that we know what a double root is.
Why is it so?
Well, it might not drawn it. It might not be a double root. It could be two real, one real, zero real. I could ask you any type of solution. You should know how to compare the discriminant,
Do you have friends in it?
right? The discriminant is what connects the A and C numbers. So you can solve them. Notice you only have one A.
You have D ones? You have
The discriminant. Oh, one real, it wouldn't be different. Like I said, find two real. It means the discriminant is more than zero.
So then we're just trying to find it so
Oh my! I'm so associated with your friends.
Alright guys, you've got your 3 problems up there. And once you feel like you've got it, you can move on. You can look at your homework.
Yo, I'm actually so.
Wait.